Hi, Royals. Before we get started with our Trig lessons, I'd like you to find the file 4.4 Trig Algebra on our class website. We're going to be manipulating trigonometric expressions in this course, and the earlier we get a start of talking about these expressions in the right way, the better. And I think since we're not meeting as a group, I'd like you to start with this. So this page has a sort of two-chart system, and it's going to show you the similarities between algebraic expressions and trigonometric expressions, which are algebraic as well. The idea is that we should have very little trouble, let's say no trouble, with the left-hand side here. If we're asked to do x plus x, we should be able to know what that is. Sometimes when we have sine of theta plus sine of theta, students treat it differently, and we really shouldn't be treating it as being differently at all. If I have 1x plus 1x, saying that and reading it in English might help me avoid the common mistake of saying this is x squared, then I understand that that gives me 2 x's. Over here, if I have 1 sine of theta plus 1 sine of theta, is not the thetas that I'm adding together. Theta is not the number in this expression. I'm also not doing sine plus sine, because sine is an operation, not a number. I can't do square root plus square root. The square root operation is waiting for an argument. Square root doesn't equal anything. It's waiting for an input. So is the sine of theta. In fact, some teachers expect you to always write brackets around your angle to remind you that it is an input, and that'll sort of drive in the idea that this is a function operation. Lots of textbooks will write it without brackets, so I'm not that picky there. In English, 1 sine theta plus 1 sine theta will be 2 sine theta. And it is these sine thetas that I am adding together. I'm going to leave some of this for you to do, so I'm going to be jumping around a little bit. Let's take a look at C. C is x times x. Those are two powers with the same base. That's 2 factors of x. I can write it as x squared. I just need to be kind of careful with the tangent of theta because it is a compound quantity. The tangent of theta multiplied by the tangent of theta. The probably safest way of writing this is the tangent of theta squared. Okay, that is acceptable. It takes a little longer to write those brackets, but it's worth it. It wouldn't be wrong to write brackets around this x either. A couple of students have had issues identifying what their base is because they didn't have brackets around a negative base, for example. Over here, I want to stress that you should not write the tangent of theta squared. This would be interpreted as the tangent of the square of theta, which we don't want to do in this course. Okay. But there is another way of writing this expression that you need to be familiar with, and it dates back to maybe issues before we had computers and we were typing things out on typewriters, that we should be able to write this like this. And it's kind of unfortunate because a lot of students are taught to read from left to right, and they'll read this as tan squared theta. And it can be written like this, but it should not be read as tan squared theta because I cannot square the tangent. Tangent is not a thing. It's not a number. This is just a convention that we're going to have to get used to. Kind of like sometimes there's words in English that it doesn't make sense that that's how you pronounce them, but you just do it because someone told you to. I guess that's what's happening right now. It's your choice. If you want to use this notation, you will definitely see this notation. There are some problems with this notation. If the tangent of theta were 3 and I wanted to square the tangent of theta, it's not entirely clear where I put the 3. In the line above, I know I put the 3 there and then I square that. Okay. Let's, I don't know, skip to, how about F? F algebraically over here, I have x times 2x minus y. I'll do 1x multiplied by 2x. That'll give me 2x to the exponent 2. And then I need to do positive 1x multiplied by negative 1y. And grade 9 students are often challenged by this question, what is x times y? They say, I don't know. How am I ever supposed to do that? Well, we now know that positive x times negative y is just the opposite of xy. It's actually easier to do because I don't need to think about it. It is x times y. It can't be simplified. try the same thing on the right-hand side here. If I have the sine of theta multiplied by 2 times the sine of theta minus the cosine of theta, I think the safest way of writing this is going to be 2 multiplied by the sine of theta. That is being squared. There are now 2 factors of the sine of theta. And then I'll do minus a factor of the sine of theta in brackets multiplied by a factor of the cosine of theta in brackets. Now, another possible option would be 2 times the sine of theta squared, written like that, but read as the sine of theta squared. And then you don't need brackets here, but you might want them. The concern could be it being clear that I'm not taking the sine of theta multiplied by the cosine of theta. I think it would be silly to assume or question about whether you'd be taking the sine of another ratio or an angle multiplied by a ratio, but I don't think leaving the brackets in there is a problem at all. Let's try some fractions. G is a conjugate, so you should recognize that situation. Let's take a look at, why don't we finish up with I? You could always, watch this and then try these on your own as well, but you should get plenty of other practice in here. To simplify these expressions, I will require a common denominator. How could I possibly find a common denominator between x and y? Guess what? It's xy. This will give me y plus x, xyths. Easier than when there's numbers, I think, because I don't have to do any calculations. Common denominator of the sine of theta and the cosine of theta is not sine cos theta. You can't multiply by cos because cos is not a number. You can multiply by the cosine of theta. Let me show that work over here. I'm multiplying by 1. I'm multiplying by cos theta, which is fun to say. Here I'm multiplying the reciprocal of the cosine of theta by sine theta. That gives me the cosine of theta plus the sine of theta divided by the sine of theta multiplied by the cosine of theta. Sorry, this is going to happen once in a while. My bracket becomes a C. I'll try to catch them. On the back, we've got a little bit of factoring. Let's factor the following expressions. We can begin with our old friend common factoring. Let's remove a factor of x, leaving us with x plus y. I have the same sort of format here, a binomial. This has 2 factors of the sine of theta. This has 1 factor of the sine of theta. Sine is not a factor because sine is not a number. I can't take the common factor of the square root of something. The sine of is a non-distributive operation. What is common here is a factor of the sine of theta. And I can check by distribution. Sine of theta multiplied by what would be the sine of theta squared? That'd be the sine of theta. Sine of theta times what would give me sine of theta times cosine of theta? There's the cosine of theta. Let's try some trinomial factoring. Let's go down to D. I mentioned earlier in the course that we might want to get used to having multiple variables. That's because we'll see that with trig here. So I can treat this as an x method or decomposition. I'm going to do x method here. Decomposition gets really long when you have longer expressions like this. So I'm going to list my factors of 1 and my factors of 1, and I multiply diagonally, and I find a product that has a sum of 2. So I'm going to put a factor of x with the coefficient of 1 there, and a factor of x with the coefficient of 1 there, a factor of y, the coefficient of 1 there, a factor of y with the coefficient of 1 there, and I can check through distribution. X times x is x squared, xy plus yx is 2xy, and y times y is y squared. So this turns out to be a perfect square. So if I want, I could write it like that, and review that x plus y all squared is not x squared plus y squared. Exponents are not distributive. Try the same thing here. Factoring this isn't any different than the factoring methods we've used because your factoring technique works on the coefficients. I find the coefficients that I want first. I'm going to need a coefficient of 1 there and 1 there and 1 there and 1 there to get products of 1 and a sum of 2. My variables are just going to be a little bit different. I'm going to have 1 cosine of theta plus 1 sine of theta. And here I'm going to have 1 cosine of theta plus 1 sine of theta. And that also turns out to be a perfect square. That can be written like this if I want. Okay. The other thing that I mentioned when we were talking about factoring is you might want to get used to factoring in a rearranged order. We had a lot of students that chose to write this as negative x squared plus 1, then remove a common factor of negative 1, and then factor as a difference of squares, x minus 1, x plus 1. Well, this rearrangement didn't happen much in grade 10. It didn't happen much at the start of grade 11, but this rearrangement is going to happen a lot in trig. So if you have been avoiding it up until now, now is the time to challenge yourself to learn something new. Okay, I have, if you want to visualize it as 1 plus 0x minus 1x squared, I can use my x method on this. Factors of 1, need to have a sum of 0, opposite signs. I put a 1 here and a 1 there. I put a negative 1x there and a positive 1x there, and I'm factored in one step, not 1, 2, 3 steps. Try that here. We also, I've discouraged memorization of formats, but I think by now, if you're comfortable with differences of squares, jump right into this. To factor this as a difference of squares, I put 1 there, I put the cosine of theta there. I make sure that they are conjugates. Maybe we have more experience from rationalizing. Check with distribution. 1 times 1 is 1. Minus 1 cos theta plus 1 cos theta is 0 cosine of thetas. A positive cosine of theta multiplied by a negative cosine of theta is the opposite of the cosine of theta squared. Okay. G and H are differences of squares. They can both be factored a little bit further as well. Review that there is no factoring for a sum of squares. You should be able to check through distribution and check the solutions online as well. Okay. This trig algebra is very important for lesson, I think it's 4.4 on trig identities. And that's why you'll find this worksheet labeled as 4.4. But get a head start on this. Take a bit of a breather. There's not really any assigned homework for this lesson other than completing that page. Okay.